Hello all you beautiful people and welcome back to the channel. So my last video on the beautiful VP8000, it did pretty well. Kinda a little bit better than I thought it was going to, so I figured I'd make a follow-up video, continuing on with what we were talking about last time and doing a little bit more in-depth analysis on this radio. I've had it for a little over a month now, and I've been using it a lot. I took it on a vacation out to Arizona. I've used it in a couple volunteer events in the area. I've taken it out to the Railroad Museum and put it through its paces out there, and so far, absolutely zero complaints. The thing is just as good as I hoped it would be. Now, truthfully, I haven't stress tested it, to any crazy amount. It did suffer a fall. Getting out of the car at the airport, I actually fell out of my backpack and hit the concrete pretty hard, and no damage, absolutely no damage. Little scuff right there, but it just comes right off. So yeah, no complaints whatsoever. So that all being said, I do have a pretty substantial list of stuff to go over with you guys. So let's jump right in. Number one, I know I said I was going to do a bunch of comparison with the Apex. However, you will notice the Apex is not here. It is in a better place. Actually, I just sold it. I got a really good offer on it that I basically couldn't turn down, so that thing's gone. And I was able to recoup a little bit of the expense that I incurred picking this thing up in the first place. And actually, that segues pretty well into the question that the overwhelming majority of you guys were asking, which is of course the price, and as a corollary, how you can buy this radio. And there's really two parts to that question. The first is, what did I pay for the radio? And the second is, what are you going to pay? So I said this in the first video. I got this at a special promotional dealer price about 6 months ago, maybe even a little bit longer than that. An email went around to all the Kenwood dealers saying, hey, you can get up to 10 of these radios at a heavily discounted dealer price for you to keep and demo and share with all your clients to try and promote the radio. That price was $2,000, 2,000 buckaroos. And when I saw that price, I jumped on a pre-order right away. I knew that this radio was going to be a lot more than that, especially considering the dealer demos have every feature enabled. And with EF Johnson, a lot of the features cost a pretty decent chunk of change to get enabled. So $2,000, no question. I put a down payment almost immediately when that came out, and I do not regret it. Now, that dealer promotion is done. It was done September of last year. And you're basically never going to find them for that price again, sorry to say. I'm not trying to rub that in, I'm just trying to be realistic with you guys. Unless you get lucky and find someone selling one of their radios from the dealer demos at a basically no profit price, you're not going to be paying $2,000. Now that being said, if you do want one of these radios, how do you get it? Well, you got to find a Kenwood dealer. I'm not going to recommend any Kenwood dealers. I'm not going to tell you where I got mine from. I don't want to do any type of promotion here. I don't want to look like I'm advertising anything. But you can just search around the internet for, Kenwood dealers that deal with the public. You can search for ham-friendly Kenwood dealers, and they should be able to hook you up with this radio for a decent price. And what do I mean by a decent price? Well, I have not officially gotten a quote for one of these things fully loaded, but the numbers that I've been seeing floating around on the internet are between $3,000 and $5,000 fully loaded, which is a lot of money, don't get me wrong. But when you compare that to the price of, say, a Harris XL200 or an Apex 8000 fully loaded new from the factory, it starts to look a little bit more attractive. I think a fully loaded Apex 8000 is like $8,000. I don't know how much an XL200 is, but I can't imagine it's too much cheaper. So again, I'm not trying to rub it in and show you how good of a deal I got with this thing. I'm just letting you know that what I paid for it was a one-time thing, and if you want one, you're going to have to pony up a little bit more money. But do I think it's worth the price? Do I think it's even worth $3,000 to $5,000? Well, that's a little bit trickier of a question to answer because even my Apex 8000 didn't cost me $3,000 to $5,000. I was able to pick that up for a really good price too, just only a little bit more than what I paid for this thing. So that's really a question I can't answer for you. If you're thinking about consolidating, maybe you have 2 or 3 radios and you want to just carry one, you've got a UHF, a VHF, and an 800 scanner radio, and you want to combine those down all into one. I talked about this a little bit last video. This thing does P25, will do DMR, VHF, UHF, 7800. I mean, it is essentially maybe even more than 3 radios in one if considering how you look at it. So $3,000 to $5,000 for a radio that does the work of 3 or 4. I mean, I like to think it's worth it. That might just be sunken cost fallacy, but I don't know. Again, you're watching this video for my opinion, and that's what you're getting. Okay, the other big question I got a lot is, how is EF Johnson Armada compared to Apex CPS? And I only played with it a little bit when I did the last video, but I've used it a lot more since then, and I'm still sold. There's a couple weird quirks with Armada that are, in my opinion, worse than Apex CPS, but there's a hell of a lot of stuff that's better. The number one thing being the speed. EF Johnson Armada is ridiculously fast. It boots almost instantly. It loads up code plugs almost instantly. Apex CPS takes at least 30 seconds just to load, and if you open up a big code plug, the code plug in my Apex was, thousands of channels and frequencies and talk groups. That thing took almost a minute to fully load in the program, and I don't have a slow computer by any means. I've got a modern Ryzen 7 computer as my main desktop, and that thing even struggled with Apex CPS. It was not a very well optimized piece of software. So EF Johnson Armada is ridiculously fast. It's also much more customizable. You can customize almost every single thing on this radio. You can even customize what the abbreviations are for everything you see in the soft menu here. So, down here you'll see you have all the shorthand notations for the various options you can have on the soft keys. You can customize exactly what those text strings are for every single soft button, which is totally unnecessary, but I love that you can do that. What else do I like about EF Johnson Armada? The templating system is super, super handy. So you can have radio templates for each radio model. So what I did when a friend of mine and myself got these radios is I created a radio template with all the same programming, and then you just basically assign that template to a radio and just change the IDs and the name of each radio, program it in, and then you can maintain one template across however many radios you have. It's super handy. I think Motorola has something similar, but you need to get into their radio management applications to do that, which is a huge pain in the ass. With Armada, it just all works. It's there built in from the get-go. Wi-Fi programming, another big thing. Again, you can do that with Motorola, but you need all the radio management nonsense set up. This just does it natively in Armada. Bluetooth programming, both radios, the Apex and the EF Johnson, do Bluetooth programming. It's pretty much a wash there. There are some interesting bugs with Armada and wireless programming on this radio. Occasionally it just doesn't respond. You'll get errors, timeout errors when it tries to connect to it. I've found just power cycling or restarting Armada fixes that. It's not a huge issue, but it is annoying, and that's definitely one of the downsides of Armada since it's such a new radio and such a new integration. There are still some bugs being worked out. Apex CPS, you hit right, the radio wrote. You never had to wait. You never ran into any weird issues like this. Another thing that Apex CPS did really, really well was import-export. So importing and exporting contacts, frequencies, channels, scan lists, all that stuff. You could basically import or export anything from Apex CPS as a XML file, then pull it into Excel and do all your editing there. That was really, really handy if you had a super large list of channels. Like when I program in the railroad frequencies, there's 98 of those, and doing that by hand gets really, really annoying. So being able to just go through in an Excel spreadsheet and drag down and just have it all auto-populate was really, really handy. Armada doesn't appear, as far as I know, to have a similar system like that. It does have a basic copy-paste. You can copy and paste channels and systems and things like that, but it doesn't have as flexible of a import-export system like Apex CPS does. But that's kind of your quick 3-minute overview of Apex CPS versus Armada. I guess the one other thing is cost. So Apex CPS actually recently became totally free to download if you have a Motorola business account. Armada does still cost money. Spoiler alert, it's really easy to find on the internet, but officially you do have to pay for it. I think it's a couple $100, or there's a annual subscription for a couple more $100, and then you get a new version every time a new version comes out, etc., etc. Just something to keep in mind if you're looking to pick up one of these radios is you may have to actually pay for the CPS, unlike Apex CPS, which in addition to being free to download from the Motorola website is super easy to find all over the internet. And no, I'm not going to be putting any links to any of those programming softwares in the description or telling you where to find them, because I do not need a nasty email from Kenwood lawyers telling me to shut the f*** up. As cool as that would be. All right, other comments on the video. Ham band operation, yes, it does work in the ham bands just fine. It does wideband just fine. There are some questions on the internet about being able to program wideband versus narrowband channels. There's an option in the radio that you can get, or I think might come standard, that's wideband disable. I think that might be from the factory how most of these radios will come. Mine does not have that, but if it does, you should still be able to program wideband deviation into any channels in the ham bands. I think that that was a big question early on, and I think there's been a lot of discussion on Radio Reference about that, and the consensus is as long as you program a channel that's in the ham band, it's not an issue. And I'm just scrolling through the comments here to see what other questions you guys had. Oh, what does all band mean? When I say all band, I said it a couple times in the last video, and it confused some people. All band is kind of an industry term. It just means the radio does VHF, UHF, 700, 800. That's opposed to, say, a dual band radio, which would just do 2 of those bands, or a single band radio, which would just do 1 of those bands. You could also call this radio a tri-band radio, but you know, the terms I hear thrown around are like full spectrum or all band, and I just say all band because it sounds less nerdy. Oh, and one more thing. Some of the astute viewers noticed a couple interesting channels at the end of my channel list here. These NAS channels. Yeah, I'm not going to talk about those, but just know if you know what that means and you're wondering if this radio can do it, yes, it absolutely can. We're going to leave it at that. Okay, now that I got all that talking out of the way, let's do some testing. I think I want to take the remainder of this video and just do some kind of basic performance testing of this radio. As I said at the beginning, we don't have the Apex to do an A-B comparison anymore, but I still think it'll be interesting to kind of see what this radio has in store. I want to do maybe some power draw testing, so how much current is it drawn from the battery in standby, turned off, you know, with GPS on, Wi-Fi on, Bluetooth on, stuff like that. What does the output spectrum look like? You know, I'm sure it meets FCC spec, but we can check that anyway just to play around with the spectrum analyzer a little bit. And we could also do some SINAD testing because I do finally have a microphone for this thing. This is the KMC 72, as it says there. And it does have a headphone port built in there, so we should be able to hook this up to the service monitor and do a sensitivity measurement to see how sensitive the receiver in this thing actually is. So now that 50% of you have probably clicked off the video, let's actually do some cool stuff. This one's for that one guy who disliked my last video and decided to stop watching because I was jostling the radio too much. I can't say for sure, but I think the radio's going to stay put in the vise. I feel like this is getting a little convoluted. That just makes it cooler. Okay, let me explain. This is what's called a test setup. I've made a few of these in my professional career and they pretty much always look this messy. But what's going on here? So the only bench power supply I have that I could put in the shot is this little USB-C powered one I built a couple years ago. It's running off of a 100 watt USB-C to 12 volt cigarette lighter plug that's plugged into my bench 12 volt rail. And it's running through a Fluke multimeter set to current measurement mode, because I don't trust the built-in ammeter. It just doesn't do well with low-resolution signals. So we get an accurate current reading at an accurate voltage, and that is going to 2 alligator clips that are clipped onto the battery terminals at the back of the radio. And I don't even know if this is going to work yet. I'm not sure if the radio will power up if it doesn't see the sensor and the thermistor lines from the battery. But I guess we'll find out. So I've got the power supply set to 7.4 volts with a current limit of 2 amps. And we're going to go ahead and power it up and see what happens. Cool. So right away you'll see what I was talking about with this little power supply. It currently thinks it's drawing about 10 milliamps when the Fluke is reading 0. And I know the Fluke is good. I've tested it in the Cal Lab at work, and it is pretty much spot on, so I'm not worried about that. But we could go even a little deeper. I'll move this over to the microamp range, and we'll see even powered off. There we go. So we're drawing about 140 microamps, 145 to be precise, 146 in the totally powered off state. So I would assume this is some very basic stuff like RTC timekeeping and maybe some kind of memory functions. So 143 microamps is basically nothing these days when it comes to a portable device. I mean, the battery is, what the hell is it? 2600 milliamp hours. So at 140 microamps, the battery's going to last, hell, like a month. Anyway, let's switch back over to the amps range and power the thing up. And let's go ahead and turn off Wi-Fi. So it's at kind of its base state. Doing nothing, just sitting on a analog channel, totally idle. Looks like it draws about 200, well, backlight on or off obviously makes a difference. So with the backlight off, it's drawing about 140 milliamps. Turn the backlight on, and I think this is medium brightness for the backlight, so it does go a little brighter, about 215 milliamps. Now let's start turning stuff on. So we're sitting there at 215 with the backlight on. Let's turn on Bluetooth. We jump up to 264, so about 50 milliamps or so. But it looks like the Bluetooth is intermittent. It's not always talking, which is what you'd want. It shouldn't always be, you know, broadcasting out to the world. So with the backlight on, that's sitting almost exactly where it was, except for when it transmits every once in a while, jumps up by about 50 milliamps. So let's go ahead and turn... Oh, wire came off the back. Remember that thing I was saying about sketchy... I should probably turn this off. Sketchy-ass test setups? Yeah. Okay, let's not move it too much. So as I was saying, let's go ahead and turn off Wi-Fi and Bluetooth again and make sure we're getting the same measurements we're getting before. And it looks like we are, about 215, 216 milliamps idle there. So next up, let's turn on Wi-Fi and see what that looks like. So significantly higher current draw when it's transmitting. Looks like it jumps up to about 320 or so milliamps with the backlight on, of course. But it does appear that it does draw more current than Bluetooth, even in idle mode. I see quite a few more little blips up there to around 260 milliamps, which implies to me that it's doing a little bit more communication. And there we can see with the backlight off, it's 140 to 180. So a little bit more active with Wi-Fi on compared to just Bluetooth, which, again, I'd expect because Wi-Fi is a little bit more involved than Bluetooth. So turning Wi-Fi off, let's turn on GPS, which I'm assuming will bump up our power draw a little bit. Now, it's probably not going to be able to get a lock inside here, so it's going to be just continually searching for satellites. But it looks like with GPS turned on and searching, we've jumped up about 20 milliamps or so, which is not too bad, but that's a noticeable difference. And that's one of the reasons that I keep GPS off most of the time unless I really, really need it for something. It's just needless power draw that you don't really need 90% of the time. So let's do something loud and annoying now. I'm going to turn on monitor. So now it's open squelch receiving. We've jumped up about another 50, 60 milliamps there. And I'm going to just start turning up the speaker. So we're right at around 200 with the backlight off and the speaker at 0. And this is going to get really, really loud. And it looks like we're peaking at around 600 to 620 milliamps with the volume at full. Yeah, this thing gets loud. It is just as loud as the Apex and maybe even louder. So let's check out transmit power draw next, and that's something I'm actually going to need to up the limit for here. Let's bring it up to, well, I hope I don't need all 5 amps of this power supply, so I guess we'll see. We'll start with a VHF channel first. This is going to be a 147 megahertz frequency. Let's make sure we are in low power. And let's see what we get. Let's see if this whole setup doesn't just totally fall apart. Okay, 1.4-ish amps, putting out 3 watts. So not too shabby. Let's bump that up to high power, 1.88 amps, and 5.15 watts. And I'll do all these efficiency calculations on the screen. I'm not going to do them in my head because I'll just get them wrong and look like an idiot. All right, same exact thing. Let's find a UHF frequency. This is 442 megahertz. Starting again with low power, 1.68 amps with 2.99 watts out, and high power, 2.10 amps and 4.7 watts out. And I don't have any 700 or 800 megahertz channels programmed into the radio, so I can't measure current draw up there, but I'm never going to be transmitting on this radio, or at least I don't think I'm going to be transmitting on this radio in the 700-800 band, and neither are 90% of you, so I'm not going to go through all the effort of throwing in special channels into my code plug and wasting my time because I want to get this video out as soon as I can. Because it's all about the engagement, baby. All right, what the hell else can we do? Oh, Synad. Let's do Synad. So there's an ill-fated video of mine that will never see the light of day where I did a really, really good explanation about what Synad is. And because I don't have the energy to do that tonight, I'm not going to go quite as in-depth, but I'm just going to tell you what you need to know. So Synad is just short for signal, noise, and distortion. They threw the I in there just to throw you off and confuse you. But all it really is the ratio of your desired signal, which in most cases is just a 1 kilohertz tone, to the total amount of noise and distortion on that signal. There's a lot of different methodologies to actually make that measurement. You know, how do you measure total distortion and total noise? I'm not going to get into that because I don't really understand it enough to explain it, and my service monitor just does it all for us anyway, so I don't really need to worry about it. But what is Synad actually useful for in the context of radios? Well, it's the way that we measure how sensitive a receiver is. There's a standard Synad value we're trying to hit, which in this case is going to be 12 dB. That means there's 12 dB of signal above our noise and distortion. That's not really a good way to describe it, but just roll with me here. Basically, we're looking to see at what received signal power does our radio hit that 12 dB mark, and that's known as the radio's sensitivity. You'll see this in data sheets. It'll say Synad, or it'll say receive sensitivity at 12 dB Synad or 10 dB Synad or 20 dB Synad, but most of the time it's 12 dB. That's just what the industry has settled on. And typical values you'll see for that on any decent radio is going to be around negative 120 dBm, which is like 3 microvolts. It's a really, really low level signal, but most modern radios can hit that relatively easily. So I haven't done this yet, and I'm actually really, really curious to see where this radio falls. So let's get even more messy wires out here on the bench and get everything hooked up. I'm sure there's some fancy test adapter for doing this the right way, but I don't own it, and I'm not going to build one. I have this speaker mic here, and that's going to be good enough. Now I need to figure out if I actually have the right audio cable for this. I'm pretty sure I made one like 3 years ago for doing this exact same thing, but what are the odds I still even have that? I think we're going to have to get a little stupid. Okay, here's what we're going to do. The output of this mic is a 1/8 inch speaker jack, so we're going to plug in an 1/8 inch speaker cable here, and then we're going to hook up the tip in the sleeve of this thing to some alligator clips, and that's going to go to a BNC cable that's going to go into the audio input port of my service monitor. This is ugly and terrible, but I've done worse things. So because I still haven't spent the $80 to get the fancy converter board to actually capture the screen of this thing, you're just going to have to take my word for it on the values I'm measuring. But we're going to put this into audio analyzer mode. We're going to set up the audio analyzer input to audio in, get rid of all the filtering, make sure the impedance is set right, and set up a Synad measurement for right here. So that's going to be reading out SINAD and our audio level in volts. And then I'm going to go over to the RF generator and set it to output RF at our test frequency, which we'll do VHF first, 147. I think that repeater is 21 megahertz. We're going to modulate a 1 kilohertz tone. We're going to do wideband, so 3 kilohertz I think is probably standard for a 5 kilohertz wide channel. And we're going to start at negative 100 dBm just to make sure that my test setup is correct. And we should be ready to go. All right, this is the high-class cinematography you guys came here for. Let's get the radio fired back up. Turn it up a little bit. I am seeing my audio level increase, which is good. Set the volume to 50. That's about 1.78 volts RMS, which should be good enough for a SINAD measurement. And right now it's just noise. And actually I can turn on the speaker and you'll be able to hear that. And let's do a SINAD measurement. So we'll go to RF Gen, turn that on. And I'm not doing something right because it's not hearing anything. Okay, I figured it out and I learned something new about the radio today. So you'll notice when I press the monitor button, it says TX channel on the display. So it's actually monitoring the transmit channel, which, since this is a repeater, would actually be 14781. So now, if I turn on the generator, we should hear a nice crystal clear 1 kilohertz tone. And we do. So right now I'm putting in negative 100 dBm into the radio, which in normal operation would be a really, really, really strong signal. We're actually measuring a SINAD of about 42 dB right now. And I'm actually going to turn on some averaging on that value because it's jumping all over the place here. And now I'm just going to start bringing down the amplitude until we get to 12 dB SINAD, and we'll see where that falls. And you'll hear it's getting a little noisier. And I'm already at a negative 123 dBm. It looks like right about there is 12 dB SINAD, jumping around 11 to 12. Yeah, I'll call that 12 dB SINAD. And we are at negative 124 dBm, which, in case you're curious, is 0.141 microvolts. That is a very sensitive radio. And I'm pretty sure my apex the last time I ran this test was right around that same number. So no problems with sensitivity whatsoever. This thing is doing just fine. So we'll do the same exact thing on a UHF frequency. We'll do that same one I did the TX test on. So 44265, but if we're the TX channel, that's going to be +5, so 44765. Turn on monitor, go to 447.65 megahertz, turn it on, and we're a little bit lower on UHF. It's hovering around 10 or so dB of SINAD at negative 124, so we'll bump that up, and yeah, just 1 dB up to negative 123, and it's up to 14 or 15 dB, so pretty much the same sensitivity, maybe ever so slightly less sensitive on UHF, but not enough to matter. If you're able to hear the difference between negative 124 and negative 123 dBm, please write into the Guinness Book of World Records, because you got some pretty damn good ears. Okay, next up I want to check out the radio's overall frequency accuracy. So basically I want to see from the factory how close to the desired operating frequency is it. For the time nuts out there watching, the service monitor here in the lab is referenced to a home-built 10 megahertz GPS disciplined oscillator. It's the Lars GPSDO design. It's sitting up above frame here, and it's been locked for about a week now straight. So we should be as close as I can possibly get in the lab to accurate frequency measurements. It's not going to be, your time nuts cesium standard level of accuracy, but for what we're doing here in the lab, it's good enough. So we're tuned to the VHF frequency 14781. We're going to go ahead and key up the radio again and see what it's measuring for frequency error. And we are looking really, really good there. The number you're going to look for is in the top left here. That's overall frequency error. It looks like it's jumping around a little bit, but averaging to only a couple of hertz off of zero, maybe just ever so slightly low, but occasionally jumping a little high. So I mean, that is excellent. I don't know what the PPM spec is on this radio, but from the factory, that is I would call that a superb frequency accuracy. And just like before, let's go up to the UHF frequency and do the same exact thing and see how close we are up there. Okay, and here we are. A little bit more error here, but not much. Maybe 20, 30, peaking at 40 hertz or so off, and that's most likely because the radio is starting to heat up and the reference oscillator inside is going to drift a little bit. But I mean, it's staying well within acceptable limits. You know, 50 hertz high is nothing. You're never going to be able to hear that or notice anything wrong. So cool. Frequency accuracy looks good. I've got no complaints about that whatsoever. And the last test I said I was going to do is a spectral purity measurement just to see what the harmonics look like on this radio. So I've got the service monitor in spectrum analyzer mode. It is currently sweeping from 100 megahertz to 1 gigahertz, and the reference level set to 40 dBm, which is 10 watts. So we're going to throw the radio on that same VHF frequency of 147.81, set it to high power. And actually, I'm going to set the spectrum analyzer to max hold, just so that I don't have to keep the radio keyed the entire time I'm talking. So here we go. I'm going to key up, and we'll see what we see. All right, so obviously we've got the fundamental there, right at 147. It's not the marker frequency is not going to be super accurate, so just ignore that. And it's measuring 36 dBm, so a little bit under 5 watts with cable losses. It's probably fine. We see the second harmonic there at 296. That's measuring negative 16. So if we do some quick math there, that's about 52 dB down from our fundamental. And the third harmonic, you can just barely see right there. It's probably down at, well, if this is negative 16, this is probably negative 24 or so. dBm, so also way down. So after that, the rest of the harmonics are just well into the noise floor. This is obviously not a super sensitive, super accurate spectrum analyzer. I don't actually own a true, fancy spectrum analyzer that can go way down into the noise floor, but this is good enough. I was just kind of curious to see if we'd even be able to see any of the harmonics, and they're there, but they're plenty low enough to meet any of the FCC specs. So we're going to do the same exact thing for UHF. I adjusted the span just a little bit because I wasn't exactly on 100 to 1 gigahertz. I was a little bit lower. So same test setup. I'm on high power on 447 megahertz, and let's see what we get. So we can see the fundamental there. And it's about 35.5 dBm, so 3-4-ish watts. And I think we can just barely see the second harmonic there, just peaking above the noise floor. I can manually move the cursor over there to get a better look. Yeah, I can't even get directly on it with the resolution here, but that's just barely above the noise floor, which is about negative 29, negative 30 dBm. So again, well below any of the FCC regulations for spectral emissions, which again, that's what we would expect. This radio's already been conformance tested and type certified for use in the US, so we know it's going to meet all these FCC requirements. I was just testing this to play with my spectrum analyzer a little bit and see if we saw anything interesting on there. So that about does it for this one. I apologize, this was not originally supposed to be a 32-minute long video, but things just kind of got away from me, and I figured since I've been gone for about a month with no posts, I might as well make a longer one to kind of compensate. And to anybody who stuck through all the way to the end, thanks a bunch for watching, and thank you to everybody who liked and commented and subscribed and shared and did all the other YouTuber shit that people normally ask you to do. It's awesome. It helps me in the algorithm, and it lets me know that I'm doing something right with these videos. I guess you guys really enjoy listening to me talk about nonsense for 30 minutes straight. So that all being said, I can't resist doing a little bit of the stereotypical YouTuber nonsense. If you like the video, comment, like, subscribe, all that nonsense. And stay tuned because I've got some more videos hopefully coming up pretty soon. Thanks for watching.